This is using synthetic division to factor polynomial completely. We want to use synthetic division to show that x is a zero of the function of a third degree polynomial. So we're going to give you this first zero of the function in the blue here. X equals negative, or x equals 2 minus the square root of 5. So in factored form, it would look like x minus, and then 2 minus the square root of 5. So we want to see, does this factor out? So we're going to use synthetic division. So we're going to factor x equals 2 minus the square root of 5. We're going to show that's a zero of the function. So our coefficients are 1, negative 1, negative 13, and negative 3. So we bring down the first term of 1. We multiply, and here's where you may want to use some scratch paper to help you with multiplying and adding, because some students make mistakes when they multiply. So we're going to multiply 1 times 2 minus the square root of 5, which is 2 minus the square root of 5. Then we add this column. So we're going to add negative 1, 2 minus the square root of 5. I'm just going to erase that. It's going to start to get messy here. And we add like parts together. So negative 1 plus 2 minus the square root of 5. The like parts are your integers. In this case, negative 1 plus 2 is 1 minus the square root of 5. So this is going to give us 1 minus the square root of 5. I'm just going to erase that scratch paper. Now we multiply those two pieces together. So 2 minus the square root of 5 times 1 minus the square root of 5. When we multiply, think of this as like foiling. So we do first, 2 times 2 is 2 outside. 2 times the square root of 5 with the negative is negative 2 square roots of 5. Then we go to inside, and we get negative 1 square roots of 5. And then we go to last. Negative square root of 5 times negative square root of 5 is positive square roots of 25. Combine our like terms right here. So we get 2 minus 3 square roots of 5. And then square root of 25 is 5. And now we have like parts again with 2 and 5, which is 7 minus 3 square roots of 5. So that's going to go back up here as 7 minus 3 square roots of 5. I'm going to erase my scratch paper. Now we add our columns. So we're adding negative 13 plus 7 minus 3 square roots of 5. We add like parts together, so in this case our integers, and we get negative 6 minus 3 square roots of 5. Negative 6 minus 3 square roots of 5. I'm going to erase my scratch paper, and I'm going to multiply this piece times that piece. So use my scratch paper again down here. 2 minus the square root of 5 times negative 6 minus 3 square roots of 5. Well, we FOIL again. Positive 2 times negative 6 is negative 12. 2 times negative 3 square roots of 5 is negative 6 square roots of 5. And we go to inside, we get positive 6 square roots of 5. And then we go to last. Nice thing happens is the middle terms will cancel out. And then square root of 25 is 5. Multiply that with 3. Then I have this negative 12 over here. Negative 12 plus 15 is 3. So this is now a 3. Add the column, and we get 0. We wanted a remainder to be 0. That tells us then that our factor is true, can be factored out. So I'm going to circle this piece right here. This is what I'm going to work with next. Now I factored out x minus 2 minus the square root of 5. That's what I factored. So I took out a degree essentially. So I'm going to drop it by a degree. So now this is going to be x squared term. This will be my x term. This will be my constant. And then my remainder. So if I wanted to rewrite this in factored form as a new function, it would be f of x equals what you factored out, this blue piece, x minus 2 minus the square root of 5. And then what I'm left with is this purple piece that I circled, 1x squared minus, and then minus 6 minus 3 square roots of 5. Now we're going to work with this purple piece and continue factoring. Now please make sure you're aware of this. When you have a radical 0, you're going to get another radical 0 at the opposite sign. So if this one up here was 2 minus the square root of 5, you're going to have another one at 2 plus the square root of 5. So we're going to factor out this from the purple function. So we're going to use synthetic division again. And we want to factor out x minus 2 plus the square root of 5. Ignore the original function. You're working with the purple one. So our coefficient in front of this one is a 1. Here's our coefficient of our x term, 1 minus the square root of 5. Here's our coefficient of our constant, negative 6 minus 3 square roots of 5. And then our factor is x minus 2 plus the square root of 5. But as a multiplier, you're going to do 2 plus the square root of 5. All right, we're ready to do synthetic division with this. So we bring down the 1, and then we multiply 1 and 2 plus the square root of 5, and we get 2 plus the square root of 5. And we add the column. If you're not comfortable with adding this column, use your scratch paper. 1 minus the square root of 5 plus 2 plus square root of 5. You add your like parts together. Well, the negative square root of 5 and positive square root of 5 will cancel. And then 1 plus 2 is 3. So you'll get 3 there. Just going to erase my scratch paper. Now I'm going to multiply 3 and 2 plus the square root of 5. So 3 times 2 plus the square root of 5. Think about this as the distributive property. So 3 times 2 is 6. And then 3 times square root of 5 is 3 square roots of 5. So that'll go right up here. 6 plus 3 square roots of 5. Now I add that column. When I add that column, nice thing happens is the negative 6 plus 6 cancels. Negative square root of 3 and positive will cancel to be 0, which is a remainder of 0. So this is factorable. So now what we did is we took out another 0 at 2 plus the square root of 5. So we drop a degree. So now this is going to be an x. This will be your constant, and that will be your remainder. So that's our last factor of x plus 3 is a factor, or as a 0, it would be x equals negative 3. If we wanted to write this in complete factored form, you would have x minus 2 minus the square root of 5, x minus 2 plus the square root of 5, and then x plus 3. And then the zeros of the function, which are your x-intercepts if you were to graph it. X equals 2 minus the square root of 5, 2 plus the square root of 5, and -3. They are your x-intercepts also. They're all real numbers.